Let's think about something for a second. What if the internet just stopped? And I don't mean just your Wi-Fi cutting out. I mean the whole thing. The servers, the data centers, all the infrastructure we literally depend on for everything. Well, today, we're going to dive into a piece of hardware that's designed for exactly that nightmare scenario. This is the RIOS Sovereign Stack. And trust me, it completely rethinks our relationship with the digital world.
Okay, so let's get right to the core idea here. On the left, you've got what they call the old world, a typical server rack. You know the deal. It's fragile, it needs a perfectly climate-controlled room, and it's totally useless without the grid. But on the right, that's the RIOS CC1000. This thing is built to be dropped, to work in the dust and the heat, and to function completely on its own. It's not just a different product, it's the difference between building a glass house and building a bunker.
And this quote right from the administrator's manual just says it all. This is probably the most important thing to understand. The entire design, the whole philosophy, is captured right here. We're not talking about IT equipment anymore. This is being framed as an essential tool for resilience for when everything else has gone dark. So let's get physical and take a look at the hardware itself. The whole system is engineered for what the docs call kinetic environments. Now, that's a pretty polite way of saying places with dust, vibrations, and shaky power. Exactly the kind of places where normal tech goes to die.
You can really see how form follows function here. You've got this IP67 rated Exo-Shell, which is basically a tough-as-nails aluminum Faraday cage. Inside, you've got 4 compute blades that are hot swappable. And you notice something missing? No external fans. It uses a positive pressure intake to literally push dust out. And by the way, that warning is absolutely not a joke. If you break that seal without authorization, the encryption keys lock themselves down.
All right, and here's the million-dollar question for any piece of critical gear, right? A drive failing in a data center is an annoyance, but a drive failing out in the field with no backup and no technician for 100 miles, that could be completely catastrophic. So how does RIS handle that? Well, the solution is just brilliantly simple, as this little protocol shows. An administrator gets an alert, they log into the dashboard and tell the system, hey, I need to remove this failed drive. The system prepares itself, and then a little blue LED lights up on the actual box. You just unlock a lever, slide the old blade out, pop a new one in, and lock it. That's it. The system automatically starts rebuilding its data array with 0 downtime. A failure that could have been a total disaster is fixed in under a minute. Okay, so we've established that we have a seriously tough box, but one docs isn't a network. So let's level up and see how these units connect to the world and, more importantly, to each other to create this independent, intelligent network bubble.
When it comes to connecting to the outside world, the WAN, the priority is independence. The main uplink is Starlink, mostly because it's got low latency and it doesn't rely on any local grid infrastructure. But what if that link goes down, maybe because of a bad storm? It just automatically fails over to a backup connection, like a 5G modem. The whole point is constant connectivity, no matter what it takes.
Now, here's the really crucial part about the local network. RIOS doesn't just make a simple Wi-Fi hotspot. No, it creates a self-healing mesh. What that means is all the RIOS units and repeaters are constantly talking to each other. If one of those nodes gets knocked offline, the network is smart enough to instantly find a new path for the data to travel. It just works around the problem. And check out this perfect example from one of the training labs. A storm rolls through and knocks out the north node, which cuts off the clinic from the school. You can see on the map the connection is broken. So what's the solution? You deploy a mobile relay, and in this case, it's a drone, right into that dead zone. It acts like a temporary bridge, and the network automatically reroutes all the traffic through it, bringing the connection back online. It literally heals itself. All right, so we have super resilient hardware and a network that can heal itself. But what do you actually do with it? Let's step inside the bubble now and look at the services that can run on this thing, completely cut off from the global internet if need be. This is something they call Project Phoenix. It's a whole suite of essential apps that run locally, right on the RIOS hardware. We're talking about things like encrypted chat, file and document storage, and even a local financial system with a Bitcoin and Lightning node. Now, when the internet is working, it'll sync encrypted backups, but when it's down, everything just keeps working perfectly. Your cloud isn't out there somewhere in a data center. It's right there in the room with you. And you might think, wow, deploying a private cloud must be super complicated. But it's actually designed for field admins, not just hardcore developers. For instance, in one of the training labs, setting up a BTC Pay server for a village ledger is as easy as typing this one command, RIOS app, deploy BTC Pay. The system just handles all the complicated stuff in the background. So, you've built your own self-contained digital civilization. how in the world do you defend it? Security in this kind of environment requires a totally different way of thinking. You have to move way beyond software firewalls to something, well, something much more fundamental.
I just love this line from their technical docs. It's so good. A normal firewall, right? It blocks an IP address. But a determined attacker can just get a new IP. RIOS aims to block the physical device itself, no matter what software identity it's trying to fake. It does this with a wild technology called RF fingerprinting. The core idea is that every single wireless device, your phone, a laptop, a drone, whatever, emits a totally unique radio frequency signature. It's like a fingerprint. The Watchtower system is constantly scanning the air, identifying all these signatures and sorting them. Green list for known friendly devices, gray list for unknown guests, and red list for anything that looks hostile. So let's see how this plays out in their intruder training scenario. An alert pops up, someone is trying to brute force a password, and they're faking their MAC address to hide. The admin just switches to Spectrum View, triangulates the exact physical location of the signal, and isolates its unique RF signature. Then they execute one band command. And just like that, the attacker's physical device is blocked from the network, permanently. It doesn't matter if they change their IP or MAC 1,000 times. Their radio fingerprint is on the red list for good. We've seen the hardware, the network, the services, the security, but now we come to the ultimate test, the system's entire reason for being, recovering from what's called a total black start event. We're talking a complete collapse of the grid and the internet. And this is what makes that abstract idea of disaster recovery so incredibly real. Every RIOS unit comes with this physical laminated red card. It's not some 1,000-page manual. It's a simple 6-step checklist for rebooting the whole system from absolute zero. Disconnect from the dead grid, make sure your generator power is stable, insert a master key, and hit the reboot sequence. And this timeline, this is how they keep what they call the 15-minute promise. It's basically the service level agreement for restarting civilization. In the first 5 minutes, power is stabilized. By the 10-minute mark, the whole compute cluster is booted up and has verified all the file systems. And by minute 15, the local mesh network is broadcasting. And all of those critical Project Phoenix apps, your chat, your files, your ledger, are live. From total darkness to a functioning digital society in a quarter of an hour.
So when you step back, the RIOS stack is really more than just a cool piece of tech. It's a statement. It really forces us to look at the fragility that we've all just kind of accepted in our digital lives. And it asks a really profound question. In a world that feels more and more uncertain, what's the real value of digital sovereignty? What does it truly mean to have a corner of the digital world that you can actually genuinely call your own?